Hello everyone, welcome to my channel Cryptoware. Today we are going to analyze a .NET executable. We'll be just performing static analysis and I'll show you how easily we can perform static analysis of a sample using just three simple tools. So this is a .NET executable, so we are not going to use x64dbg because the compilation or the process of compilation is very different. We are not going to get into that, but since the compilation is different and that is why we are decompiling it using some other tool, and I'll show you which tool I'm using. Also, this I'll be sharing the hash of this sample in the description so you can analyze, and this sample is not packed, although this is a very recent malware sample. Like, it is kind of trending, but it is not packed, or maybe it has been already unpacked, but the sample that I have is unpacked. And how we can statically gather a lot of information from an unpacked sample, that is something that we are going to learn today. So the first tool that we have used is PEStudio. This is a very basic tool that we use for identifying and gathering some information related to the executable file or a PE file of any sample. So as you can see, the virus total has already given us some verdict, like it is already malicious 55 out of 71. As I mentioned that the sample is not packed, so it has already checked all those strings which could be potentially malicious, which are actually trying to perform some kind of activity. It tells which MITRE technique has been used. We can also see a URL, which could be probably a CNC server, command and control server. I have discussed about what a command and control server is in my previous videos, in my initial videos. I'll share the link of those videos in the description as well. You can go through them. So it's an executable 64-bit. As I said, that it's a .NET file, so you can see. Another thing that we can see the module name, since it is a .NET file, so we will get a manifest name, sorry, which is my application.app, and also the file name which is mentioned over here is svchost.exe. Now, SVC host is actually a genuine application in the Windows, but here we can see the name has been used over here, SVC host. So either it is trying to act as SVC host, maybe this sample once executed may behave like as if it is svc host.exe. So whenever we try to check task manager or process explorer, so we will see the name of svc host and we'll think that no, this is a genuine application. So this could be one possibility. Another could be that maybe it is performing some kind of injection. We are not sure of it, we are just guessing, but using this name makes it a bit suspicious as well, along with the fact that it has already been marked as malicious by virus total. Here you can see the score. You can see some of the names that have been mentioned is backdoor, MSIL, blacknet rat. So most probably it could be a rat remote access trojan. What other information that we can get is DOS header, DOS stub size, file header. Let's look for directories. So you can see some information related to that. Let's look for libraries. So the basic libraries that it has used. Import, you can see that the imports option show a lot of functions which have been flagged as malicious. Now what happens if I give you an example of for example, process start info, or sorry, it has not been marked as malicious. Let me choose the one which has been marked as malicious over here. Okay, for example, get current process. So the function itself does not mean that it is malicious. So this function has been used by a malicious author or a threat actor to perform some malicious activity. So here it is trying to get information about the current process, maybe its ID, what is it running, what other information that you can get about the current process. So it is get trying to get those information. Now, how that function is being used by a malicious author, makes it malicious, and that is the reason why it has been flagged as malicious. And that is why we can see a lot of import functions have been marked as malicious over here. They may not perform any malicious activity on their own, but they are a lot of times used by malicious authors for the same. You can see the strings, there are lots of strings. Even the strings have been marked as malicious. For example, get environment variable has been marked as malicious, or from base 64 string. So we can understand that there has been a usage of base 64 string somewhere, and this function or this string is being used to maybe decode this. So again, this string, or if it is a function, it is not a malicious function actually, or a malicious string, but the reason why it is being used, or the way it has been used, makes it as malicious, and that is why it has been marked or flagged as malicious over here. So from PEStudio we have gathered a lot of information. Let's go to detect it easy. So detect is it easy is another tool from where you can actually identify that whether it is packed or not. Of course, you can understand or identify if if a sample is packed or not from PEStudio as well. If you check the entropy, for example, if we go here and you can see the file entropy 5.1, it is comparatively low, because if a sample is packed, you will mostly see the entropy to be around 7 or 7.99. It will never go beyond 8, but it will be somewhere between 6.5, more than 6.5, or 6.8, 6.99, then 7. So if you happen to see it that way, then it is packed. Also, there are another ways, like we won't be able to see so many strings that we are able to see, we won't be able to see so many import functions that we are seeing right. So get checking in detect it easy, it will tell you like what kind of linker has been used, which compiler has been used. It also mentions if it is packed, and when does it mention it. It mentions it on the basis of some packer listing that it already has. So based on that it mentions, so if it has used any common packing method or tool, for example UPX or Empress, you'll be able to see them. Okay, they also have their signature from where you can actually identify if it has been UPX packed or not. So here we can see that it is not packed, and we are pretty sure that this is malicious as well. So we'll be using our third tool, which is ILSpy. You can always use any decompiler, .NET decompiler of your choice. DNSpy is another one. I prefer using ILSpy. You can use any tool of your choice, of your convenience. So here you can see that it has already been loaded. So, okay. So here we will start looking at some of the details, what information is there. Okay, these are some basic information. We just want to look at the code. So, see, the decompilation has happened using this ILSpy. So, that was a .NET executable. So, from there, it has been decompiled. So, you may see some essence of how the variables have been named, because, of course, we cannot extract the original code out of it. So, it is somewhat similar, like what would have been written, and that is how we are actually analyzing. So here we are getting all these kinds of information, so we can move to other information. Let's skip this also. Let's go to resources. Let's go to SVC host. This is something that we observed. Okay. Okay, so what all information we can see? Anti VM string, anti WD string, SCH task string. So there are lots of information which actually gives us an idea of what it could possibly do. Like even without looking at the code, I can we can identify that maybe it is using some anti VM techniques. Maybe what could anti WD means? Maybe Windows Defender that it is trying to mean. ASCH task, maybe it is trying to schedule some task. So these are some ways how you are actually identifying. HTTP. So you can just double click on them and you can see if you are getting some information. So let's go here. So as you can see that there is a form 1 function that has been defined, and here you can see a URL. Yeah, I hope this is better. Yeah. So here you can see a URL, the same URL that we saw in PEStudio. ID is hacked. We can see some start name that has been used. Installation name is Windows update.exe. So maybe it is not SVC host that we thought of it as. So maybe after it gets installed, it the installation name becomes Windows update.exe, most probably. So it has a dropper path, dropper name. What all information can we get? File info. There's some more information. Some temporary path, most probably. Again, it is making a new HTTP connection. So it could be like we are more confirmed that this is CNC and this is malicious, and some connection is being made with that server. So it initializes the component. Now we clicked on initialize component. We are not using any debugger or anything. We are just using a disassembler to identify and see what it is most probably doing. So we went to initialize component and we can see some more information. It is using form 1, the one that we have used. It says Windows update. So maybe if somebody has downloaded this executable, they may think of it as an executable. Okay, so debugger step through. Let's see what does it mean. So there are few things that it has used. Okay, let us go back to other functions that we were trying to see. So in form 1, what else are we going to see from here? So we observed, we had seen that it was trying to make an HTTP connection, some dropper path, something. Let's scroll down. We went here, we saw this. Let's see some check admin. So here what it could possibly be doing. So there's a function check admin, Windows identity dot current, Windows principal. So it is trying to know what is the role and if it is admin or not. So is in role Windows built-in dot administrator. So it is checking, right, if it is an admin or not, because it wants to execute it. So it is also using a check USB function. And here, if it is checking that they have already defined a temp path that we saw previously. So if this file exists and ends with this, they are checking if this is happening or not, if this file exists in the specific path. So maybe they are trying to spread it through USB, most probably. Get antivirus. So it is maybe trying to look for what all antivirus is over here, most probably. So yes, so it is checking it from here. It is running a query, select star from antivirus product. It is checking for what all antivirus projects. So the final thing, like before getting executed, these are few of the things that it is trying to check. Okay, we'll just get to the important ones for now. So here we can see that some environment functions have been used. It is also gathering some information here, system drive, file system, some information related to that. Open browser, so maybe it is using web browser, and okay, it has written it as web page has been opened in hidden mode. So maybe it is trying to run something, it is trying to perform some action, and it is keeping it in the hidden mode. Most probably it has kept it in the log. In the PowerShell, it is also trying to run some PowerShell commands, which you can see that has used PowerShell execution policy bypass. Again, it is trying to run it by keeping itself hidden. And the temp name is the path that we saw over there previously, I mean to see. So it is executing PowerShell. There are some program list that is trying to check. So it is looking for, it is trying to find some folder path, some directory information. It is trying to append some text over here. So it is adding some program list file. Okay, so it has used some random array over here, which it may be using for some other function, for some other activities. It is performing some ping function, trying to get the location. Again, it has kept everything in the hidden mode so the user will not be able to identify. Start work. Let's see this steal Chrome cookies. So most probability is trying to steal the Chrome cookies. So here you can see that it has given the default path of the Chrome after installing it. So from there it is trying to gather those information. Again, there is steal FF cookies. So mostly Firefox cookies it is trying to steal in the similar manner. This is steal passwords. So it is trying to gather more information about the password. So this is the base 64 that we saw before. We can actually have a look. See, this is using some upload, some delete. So if you want, you can check what this base 64 uh, encoded string means. So after decoding it, this is the meaning of it. Password stealer dot steal password. Scrolling below, we observed a lot of activities that it is trying to perform. Let's go to these section. So here we can see some anti-debugging. Let's see what it is trying to do using anti-debugging. So here you can see that it has used an array of a lot of monitoring tools that we use, like Process Explorer, SBI Control, Spy the Spy, Wireshark, a lot of them, Process Hacker, that we actually use for performing dynamic analysis. One of the reason why am I not performing, but here I can actually make the changes and recompile it and I can run. So I'll be able to bypass. This is one of the possibility that you can do. We will have to also look for what other checks that it has performed. So we need to bypass them all to perform the dynamic analysis. Here you can see that what all antiviruses scanners that have been used, that they have mentioned over here. So process and process, so it is basically killing the process if it happens to find anything like that. So it won't run, the sample will not run if it happens to see any such kind of application running, any monitoring tool running. Let's go to anti-VM. So in anti-VM, yeah, here we can see that it is looking for two DLLs, dynamic link load library, so which is VM guest lib.dll. So this is related to the DLL if you're using your VMware, if you're using VMware, and this is for VBox, VirtualBox. So if I happen to execute it even without running any monitoring tools, since it is running in VirtualBox, it won't get executed. So that is also another thing. So we can actually bypass this because we are able to see the code and we can remove this section and we can recompile it. We can see if it works. Most probably it should, but you never know. So there's disable WD. Okay, just reached somewhere else. Yeah, yeah, sorry. So here you can see that it is trying to check some information related to Windows Defender, not information related to it, is making registry changes. So most probably it is trying to disable the Windows Defender and all its functionalities like anti-spyware, real-time protection. So see, you can see it is making the changes from the registry, disable, scan, on real-time, enable, all those things. So it is using registry edit, and that was the reason why it needed admin privileges, maybe. Some more information: SVC host, DDoS. We can ignore some of them and we can look for the important ones. Let me check. Yes. So here, the one which is really important is persistence. So here that I wanted to discuss is how it is trying to gain persistence over here. So what it wants to perform and what it wants to gain from getting persistence. So what happens that even if you happen to identify or maybe you see some unusual activity, you may try to reboot your system, but even after rebooting, the sample stays into your system. So it has created a persistence, so it will stay over there. It will execute itself as soon as the system starts. So it will again perform all those functions like identifying those monitoring tools, turning off the antiviruses or the defender, making changes in the registry. So it will be performing all those kinds of activities. So here it is trying to uh, add itself to the scheduled tasks.exe. So it is creating on start and it is giving a path to itself. Again, it has kept it in Windows hidden so that, uh, of course, the user will not be able to identify. Again, another section where you can see what it is trying to do is it is opening this registry. So it is trying to make it writable. Again, it is making a change in the registry key, in the registry, apart from the one that we observed before. So here again it is trying to gain persistence. So as soon as the system starts, it will get executed. This is the registry which is used for that purpose. Again, startup, this is the same one that it is trying to execute. Let's go to USB spread. Okay. So here another interesting thing that we can observe is object LNK. Okay. Since it says USB spread, so maybe it is trying to spread itself through USB. We already observed how it is looking for path, if that specific .dat file is present over there or not. It is checking all those things. Before we did observe all those things. Now here what it is trying to do is most probably it is trying to create an object using WScript shell, and it is trying to create a shortcut with a new file name .lnk. So a lot of times these LNK files are also created and they are targeted in that a way like so that they get executed. So LNK is a shortcut file, and this is also one way how they are trying to make sure that their sample gets executed. So if a system restarts or reboots, even at those points of time, also these should work. So here it has mentioned target path, working directory, or maybe this LNK could be used to execute another executable. Okay. So here we can see that it is making all those changes and it is updating it using wscript.shell, and it is creating a shortcut over there. So here USB drive related some information and some activities that it is trying to perform. So a lot of times we see that some shortcut files get created in the USB. So that is how it spreads a lot of time. This is how they sometimes create the shortcut files. Actually, most of the times, this is how they do it. So from all these very basic static analysis, we can actually gather a lot of information. Like it is trying to uh, create some persistence. It is trying to create a lot of it is trying to spread itself through USB. It is trying to create shortcut files. It is trying to connect to a URL, most probably the CNC server. What else it is trying to do? It is trying to, yeah, it has all those anti monitoring, anti detection, anti debugging techniques. So from all these things, from it is of course an unpacked sample. So from an unpacked sample, it is really possible to gather all these kinds of information. So we have gathered these information from here. So whenever there is a sample which is packed, an executable, Windows executable, and if you happen to unpack it, you can actually identify and gather a lot of information just from static analysis before getting into dynamic analysis. Now, before performing dynamic analysis, since we have performed the static analysis, how will it be helpful for us? Now we have identified what all checks are mentioned over here. So we can make those changes, we can recompile it accordingly, and then we can execute and see the activity. We can monitor those activities, and the sample would run successfully in those cases. And that is the reason why some sort of, to a very good extent, static analysis is important. So that's it for today. Thank you so much for watching this video. We will be analyzing some more samples in our upcoming videos. We'll be using static analysis, dynamic analysis. We'll be deobfuscating more samples, and gradually we are moving to a bit tougher section. Before this, we were just statically analyzing samples using just two commands, which were files and strings. Now we are actually analyzing and understand what could a sample possibly be doing. So stay tuned. We'll see you in the next video, and thank you so much. Bye.